Okay, so next up we have a talk about beyond big data, taking advantage of the fourth industrial revolution. This will be presented by Ms. Jane Zavalishina, CEO of Yandex Data Factory.
Thank you very much. Thank you. Thank you for inviting me here. In fact, of course, today, I think no conference on startups, technology can get on without mentioning big data probably a dozen of times. But I believe that in most of the cases, people actually don't think about big data the right way, therefore missing most of its value. That's how most people think of big data. They imagine that we as humans now may have much more information about what happens around. We can know better what our business is about, what our customers are, and so on and so on. So it's all about knowledge. But in fact, I strongly believe that the biggest mistake, or the biggest error on this picture is this human. And it's not only me who thinks so. This is a quote from McKinsey's Executive Guide to Machine Learning. You see, they put it quite a harsh way, right? Human-in-the-loop involvement is rapidly becoming impractical. And you see, they are not talking about some physical work. They are talking about decision-making. What would that mean? Again, if you are interested, there is also Harvard Business Review from the last summer. The whole issue is dedicated to exactly this topic. How do we deal with this new type of employees we all should think about, which are, in fact, algorithms, machines, which are based their decisions on those big data we're mentioning. Of course, we all heard about the most prominent cases of machine learning, or you can call it artificial intelligence. We all know Deep Blue, which won over human in chess. We all heard about self-driving car, which Google now develops very, very intensely, and IBM Watson, which helps doctors, and so on. But when we think about it, okay, I mean, it's all interesting, but what it has to do with our day-to-day business, right? We don't play chess for a living. So what it has to do with our businesses and why, on earth, McKinsey is issuing an executive guide to machine learning. Well, let me give you another example, which is much closer. Yeah, it's in Russian. You cannot read that, I know. It's supposed to be this. Because it's Yandex. Yandex is our mother company. It's the biggest Russian internet search and portal. And as a big portal, they have part which is Yandex News. Yandex News, these are just top 5 headlines. And if you go deeper inside, you will see Yandex News, which looks pretty much like any online media. And if you look at the audience of Yandex News, you see there are top 10 newspapers by digital traffic. So you see that if Yandex News would be considered newspaper, it will be seriously like within this top 10. And now just guess. Here's the media with 23 million monthly readers. What do you think is the size of the editorial team? You probably already guessed, right? It's 0. There is no editorial team whatsoever. What actually happens in Yandex News, it gathers the news from all kinds of media, all kinds of sources. The smart algorithms, they are grouping them up into the coverage on specific topics. They choose the best picture to show with this topic. They choose the best headline for this topic. And they also choose those 5 most interesting news for the first page of Yandex. It is all automated. It is all done by algorithms. There are a lot of decisions involved, right? They are not decisions like strategical ones, but these are decisions, and we do not need humans for that anymore. But of course, it's not limited to internet itself. From our experience of applying machine learning algorithms to other industries, we see a lot of potential applications for it. What basically happens when you use this machine learning employee is that you take a lot of historical data, you take this smart algorithm which looks at the data, figures out the patterns, and based on this data can build the predictions about what's going to happen, and based on this prediction can actually make decisions. One of the problems which is solved just very, very good way with machine learning is churn prediction for telecoms. Why it's interesting? Because, in fact, telecoms were thinking about churn prediction, they're working on it, well, for probably decades, because it was always important for them not to lose their customers. So they have big analytical teams which are thinking about it and trying to make sure that customers stay with them. And still, it seems, while they're all smart analysts and very qualified, have all their data around, it seems that if you just take good enough machine learning algorithm and, well, smart data scientists to apply it, you can easily increase the results, well, at least 5%, which will already give you millions of dollars in saved revenue from these customers. The same example we've seen in retail banking. That was a specific case for one very big retail bank. They have huge customer base. They are not very much interested in attracting new customers, but they want to monetize the existing customers better. So they offer them something additional to the package the customer already uses, like upsell, cross-sell activity. And again, it seems that if we take machine learning algorithm and we analyze all this previous data about customer transactions and our previous offers and reactions, the prediction we can build is so much more accurate that offers sent according to this prediction generate 13% more money than in their normal process with their human analysts, which know everything about banking, but they are not as capable as a machine in this particular task. But again, it's not limited to just retail and analyzing consumer behavior. It seems that the same principle works for the data generated by equipment. That's another real-life example. If you take a steel-making process, you will see that it's actually quite a complex process, and you have very experienced operators which are making decisions on how much ferroalloys put into this steel mixture to make sure that you receive the necessary quality of steel. And this decision, of course, is based on the information. They have the screens you've seen before, right, in the first slide. They have a lot of data, they have physical models, and still, if we use machine learning algorithm to analyze the same data, it builds predictions more precise. So you can put less ferroalloys into the mixture, still ensuring the same quality, and saving millions of dollars a year. Just another example. It's even closer to firing people out, because in fact, this big online dating site was employing a couple of thousands of people in some very warm country, manually checking the pictures which users post on their profiles, just to make sure that these are pictures of humans, they don't contain any inappropriate content, and so on. And again, if you employ algorithm, it seems that you can do it at least as accurate as humans. It's just so much more cheap, and also it's much faster. So why we are talking about industrial revolution here? What is so important about machine learning? Well, you see this quote about not only gadgets, but innovations of various kinds in agriculture, transport, manufacture, trade, and finance, started up with a suddenness which is difficult to find a parallel at any other time or place. But this is quote, it's not about today. In fact, it's a quote from a book about the Industrial Revolution of 18th century. And that is why you can see more and more often that when people think about machine learning applications and artificial intelligence, they start speaking about it as the fourth industrial revolution, because it's relevant for pretty much any industry, for pretty much any business, because data is nowadays everywhere. And it's one more thing from the same McKinsey's Executive Guide to Machine Learning. I almost missed it, but you see, they consider machine learning as a mainstream management tool. Can you imagine that? Do you know about machine learning as a mainstream management tool? Well, probably not, so you probably also have questions. And the key question is, okay, let's say we believe that this is a huge thing that's going to change our industries. I strongly believe in that, and I advise you too, because it's going to happen, do you believe it or not? So the real question is where to start. How do we choose the right way to start? First of all, if you are actually thinking about applying machine learning, the thing is that algorithm can be very efficient in making those decisions for you, but in only specific conditions. one very important thing is that algorithm cannot explain you why those recommendations are done. So the key thing for machine learning application for you would be, first and foremost, very specific economic value you are going to achieve and you can measure. That is very important because otherwise you don't really know does it work or not. And that's why, well, for example, we hear a lot about self-driving cars from Google, and lately we know about Uber's initiative in that. But I personally believe that in the real life world and like the real production mode, we'll probably see self-driving trucks earlier than cars. Why? Because there is very specific and big chunk of money to be saved on that. So that is the first time you need to decide about your machine learning project. What is your KPI? What is it you are going to achieve? When you know that, you should look for the data. And again, we should think about the data differently when we are going to provide this data to our machine learning employee. Because for humans, and that was a real example from precision agriculture, from agriculture company, they asked us to help them building predictions about how to treat their crops based on the historical data. The problem was they do have historical data for a lot of years, like 8 years or so, but it's not raw data from the equipment and sensors, but it was kind of reports, aggregated data, already processed by humans. And that actually doesn't work for the machine. While banking enjoys much more beneficial position in that because they very often they're even obliged to store the raw data from different kinds of equipment and billings. Why it's so important to have the data raw? Because in fact, when the data is cleaned up, structured, nicely understood by humans, it means that we already lost some data out of it. When it's raw, machine looking into the data and searching for patterns can figure out totally different factors than you as human would guess. Which means that when you start cleaning up your data, structuring your data, putting them in order, you basically make them worse for the machine learning. So this is a very specific, very characteristic of a machine learning algorithm. It needs the data as raw and dirty as it comes. On the other hand, it's a good thing, right? You don't need to start big data infrastructure project before you launch your machine learning project. You can start with whatever data you have and see how it goes. The third very important thing is ability to experiment. Because the algorithm is not able to explain itself, because it considers so many factors, and explanation would actually, well, it kind of exists. It's just too complicated for a human to understand. So you need to be able to kind of check that the prediction or prescription provided by you, the decision provided by you, for you by the machine, is actually correct. And for that, you need to be able to experiment. And again, sometimes there are problems with that. Like, for example, it may just not be acceptable. We had a very successful project in HR recruitment for a big retail company with tens of thousands of employees they hire every year because of high turnover, employee turnover. So if you can predict better which employee will potentially stay with company longer, obviously it saves you tons of money on this recruitment. But after that, this company reached us and they said, okay, could you please also help us with figuring out how to tune up our motivation system to make sure that we actually motivate our employees the way they bring more money to the company? And the thing is, technically, it is possible. Technically, we can use machine learning algorithm, build a predictive model, and see how it goes. The problem is, you cannot experiment. I mean, for this kind of experiment, what would you need to do is to take a random slice of your employee base, and for this random slice, you need to impose like totally unexplainable new bonus system. It's usually not something that companies are willing to do to their employees. So unfortunately, that's not the best case to use machine learning. Another problem with ability to experiment that you can sometimes bump into is just cost of this experiment. Like, that explains why, in fact, in most of the marketing nowadays, they already do employ a lot of machine learning algorithms everywhere, just because experimentation is so cheap, right? You just put some advertising campaign out there, and you see how it goes, and, well, worst case scenario, it's not very efficient. On the other hand, predictive maintenance, it's another application for machine learning. It means that you analyze all the data generated by equipment and the previous equipment failures, and in fact, based on that, you can predict when some piece of equipment is going to fail. And it's known that such predictions can be, in fact, quite accurate. The problem is, if you want to use it to save your money on the maintenance, it can be very risky, right? Let's say the standard protocol says you need to service some piece of equipment once in half a year. But you see this machine learning-based prediction that everything is fine with the machine. So maybe you can just save this money and not service it. Well, that's about risks. If the prediction is wrong, how much do you risk? $1 million cost of equipment? Probably you don't want to start there. So you need to consider if you can actually put the results of this machine learning prediction or decision into the real-life process, experiment with it. Would this be acceptable from our human points of view? And it's not too costly. Last but not least, automated action. In fact, in many cases, the machine making this decision can also, well, basically execute it. Well, the simplest example is, of course, in marketing, right? When we see that we should offer this particular customer this particular product or offering, we can just send it automatically. We do not need humans involved. And in this case, we can experiment quickly and measure results very thoroughly, and we can be sure that we actually apply this efficiently. The problem appears when humans should act on machines' predictions or prescriptions. Again, another example, one of the colleagues of us, they are a machine learning company called SalesPredict. What they do is called lead scoring. If you use online CRM, where all of your leads and potential deals are stored in and analyzed, they can look into it, add to it some LinkedIn data and other data they analyze, and they can basically predict which one of your leads are more probable to lead you to the closed deal. And they sort them according to this probability. The problem is, when a salesperson looks at the list without any explanation why, they're really hesitant to act based on that. So if you want to start applying machine learning technologies and machine learning projects as quickly as possible, I suggest that you choose some specific application where you can act automatically and you do not need humans acting based on the machine's recommendation. So that's what we think about machine learning. We think it's one of the biggest things for the next decade because it can improve and automate so many different things in so many different areas. And we strongly believe that in all the cases where we know exactly what we want to improve and we can measure it, so we can put specific KPI to the result of our business process, and we have enough data for the algorithm to analyze, and we also can afford experimenting, putting into the real-life machines suggestions and measuring how much better effect we have, and especially if we also can take an automated action, we strongly believe in all these cases, in probably 10 years, we'll actually have algorithms doing this work. Thank you very much.